What can be learned from metabolic maps? Published by sites.google.com. Metabolic maps. A subway map of the metabolism. Metabolic maps portray the principal reactions comprising the intermediary metabolism of carbohydrates, lipids, amino acids, nucleotides, and their derivatives. A metabolic map, indicating the reactions of intermediary metabolism and the enzymes that catalyze them. More than 500 different chemical intermediates, or metabolites, and a greater number of enzymes are represented here. Metabolism. 1. Catabolism. Degradative pathways, usually energy-yielding. 2. Anabolism. Biosynthetic pathways, usually energy-requiring. Metabolic maps portray the principal reactions of intermediary metabolism. When the major metabolic routes are known and functions are understood, the maps become easy to follow, in spite of their complexity. Dot and line represent intermediates and enzymes, over 1,000. One interesting transformation of the metabolic map represents each intermediate as a black dot and each enzyme as a line. In this way, more than 1,000 enzymes and substrates are represented by just 2 symbols. A dot connected to a single line must be a nutrient, a storage form, an end product, or an excretory product. A dot connected to just 2 lines is probably an intermediate in one pathway and has only one fate in metabolism. A dot connected to 3 lines represents an intermediate that has 2 metabolic fates. See Figure 17.3 and Table 17.2. 2. Organization in pathways. Pathways consist of sequential steps. The enzymes may be separate, may form a multi-enzyme complex, or may be a membrane-bound system. New research indicates that multi-enzyme complexes are more common than once thought. 3. Alternative models can provide new insights into pathways. The traditional view of a metabolic pathway is metabolite-centric. Julia Gerard has proposed that a protein-centric view is more informative for some purposes. A simplified version of the protein-centric view where proteins in the pathway form multifunctional complexes. 4. Multi-enzyme systems may take different forms. A. Physically separate, soluble enzymes with diffusing intermediates. B. A multi-enzyme complex. Substrate enters the complex and becomes bound and then modified by E1 to E5. No intermediates are free to diffuse away. C. A membrane-bound multi-enzyme system.